SNS institution, a multidisciplinary global institution and the first institution to implement design thinking curriculum in education. Our institution works based on a holistic 5-group building centers. The 5 pillars are Center for Learning and Teaching, Skill and Career Development, Center for Creativity, Industry Institute Partnership Cell, and Social Responsibility Initiatives.
Welcome to one and all watching my video. I'm AK Lavanya, bonded in SNS College of Engineering. I've joined the repeated course called Artificial Intelligence and Data Science. Artificial intelligence impacting the future of virtually every industry and every human being. AI acts as main driver of emerging technologies like big data, robotics and IoT, and it will continue to act as technological innovator for the foreseeable future. So I chose this degree for my better future career. It is very great opportunity for me to join SNS College, as they have provided many ideas before starting of the college in the way of conducting virtual bootcamp and Ideathon, where I have learned the concept of design thinking. It is the first institute in India to delineate design thinking for students' betterment. Now, in this video, I am here to present you design thinking in healthcare. Let's know about design thinking. Design thinking is a 5-step process to come up with meaningful ideas that solve real problems for a particular group of people. The process is taught in top design and business schools around the world. It has brought many businesses lots of happy customers and helped entrepreneurs from all around the world to solve the problem with innovative new solutions. Design thinking consists of 5 steps. Empathize. Understanding people's problem as a whole and gain real insight into users and their needs. Second, define. We need to define the problem, accumulate the information and analyze the problem. Third thing, ideate. We need to generate our ideas, think out of the box for the problem and identify innovative solutions to solve this. Then prototype, creation and experimentation. It is an experimental phase. This aims to identify the best possible solution for each problem found. We need to start to create solutions for the problem. And the final step, test. We need to test the prototype build so that actual user in need can gain use of it. I came up with the problem in healthcare. That is, describing tumors and anatomy in images by hand. That is, diagnosis in cancer requires high accuracy and it's time consuming. Manual counting of target structures, tracing anatomy in current tools takes hours. In Ideathon, which is conducted by my college, where Dr. VIJETHA SHASTRY sir discussed technological development that changes future. Let's move to the first step of design thinking, that is, empathize. A cancer diagnosis can affect the emotional health of patients, families and caregivers. Let's take an example. If a man has his routine life thinking that he has a healthy life, but suddenly comes to know that he has cancer, his life affects. Like common feelings during his life-changing experience include anxiety, distress and depression. These can lead to suicide attempts also. Roles at home, schools and work can be affected also. It is important to recognize these changes and get help when needed. Coming to second topic in DT, that is define problem. The delays in cancer diagnosis may occur throughout the diagnostic pathway. Like first of all, patients, primary care. It focuses on patients' wellness and it leads to secondary care, that is helping their problems. Patient treatment delays may occur when a patient fails to recognize and act on suspicious cancer types. First, patients are unable to identify what cancer types they are facing. Sometimes it is symptomatic and asymptomatic. Poor public awareness also causes. Considerable diagnostic delay might occur if several invasive procedures are needed to confirm the diagnosis and the suitability for surgical treatment. The problem is, if they can identify diagnose in a short period of time, they can have a plan in treatment of the patients. Third step in DT is Ideate. Ideas that can be implemented for the problem is as follows. That is 5 steps: quickly understand, identify, target, mapping and treatment. That is, using AI in diagnosis is the future now, as it will be able to collect measurements from scans in more accurate manner and integrate this information with multiple sources to achieve definite diagnosis and more focused treatment. Medical imaging is a main component of modern medical science and practice. Without it, we cannot diagnose the human body. Like X-ray, CT scan, MRI scans, these are the main fields which is needed for diagnosis of disease, so that we can map and plan for treatment to be done to cure the disease. Coming to the journey of medical imaging, in 1895, first medical X-ray image has been discovered by William, and then later on in 1972, PACS system, Picture Archiving and Communication System, has been developed, which can store 2D to 3D images, which allows a chronological view of patient's radiology history. With PACS, surgeons can see images before their patients return to an exam room. And then, for over 15 years and more, the promise of automated segmentation of images for radiotherapy planning has remained unfulfilled. To fulfill the needs, here comes AI in radiomics. Artificial intelligence is emerging in radiotherapy. Coming to the important part of design thinking, that is prototype. We are using open source InnerEye deep learning toolkit for this project. As with the InnerEye ML model we have trained on our data, we now observe consistent segmentation performance to a standard that matches our stringent clinical requirements for accuracy. The goal of this InnerEye toolkit is to democratize AI for medical image analysis and empower developers at research institutes, hospitals, life science organizations and healthcare providers to build their own medical imaging AI models using Microsoft Azure. To build trust in ML models, it is important to follow industry and community best practices for reliability, accountability and transparency. So, to make this research as accessible as possible, we are releasing InnerEye Deep Learning Toolkit as open source software. Let's see the clinical workflow. First of all, they undergo tomography scans. Later, radiation oncologists may need to annotate the scans to identify target tumors and the surrounding healthy organs, which are later used to create a dose plan to guide the treatment. The treatment is delivered in multiple fractions with lower dose amount. This task involves radiation oncologists or specialized technicians manually examining and marking up dozens of 3D computed tomography image scans. This may take 1 or more hours currently, depending on type of cancer. Our research shows that ML can help reduce this burden on clinicians by decreasing the time for doing this task to a few minutes. You can see in left hand side, traditionally this involves building and maintaining elastic clusters of GPUs, which is not what ML researchers and developers necessarily want to spend their time doing. And if you see in the right hand side, the toolkit makes it easy to train high performance models with assembles and deploy your models using Azure Machine Learning or Azure Stack Hub. ML could fit on this process and augment it in a clinical useful way by using Azure Machine Learning and Azure Stack Hub. With the help of it, we can automate countering process. Deep learning models provide an accurate initial set of counters. In Azure Cloud Computing Service created by Microsoft for building, testing, deploying and managing applications and services to Microsoft managed data centers. Coming to the last step of design thinking, testing. UK Hospital first to use AI cancer treatment tool. Addenbrooke's Hospital in Cambridge is the first hospital to set AI deep learning tool from Microsoft Research Cambridge that accelerates the treatment of cancer patients. To save clinician time and empower them, it aims to deliver the right treatment at right time. Artificial intelligence shown by machines made by humans. Cancer patients can be diagnosed early so that doctors can treat patients soon. Quantitative radiology can be taken, radiology can be studied, and the surgical planning can be done soon as possible to treat the patients. Augmenting dose planning with AI is now in process. As it's said by Xavier, Principal Research Manager at Microsoft Research Cambridge, AI models trained with inner eye are changing the way cancer is treated, speeding up the process to give patients greater peace of mind, as the patients can be diagnosed early and they can be treated soon, so that patient's mind will be happy. So, my project using design thinking, I came up with a solution for my problem. I would like to conclude my project by saying, artificial intelligence integrated with human intelligence is the future now. I wholeheartedly express my gratitude towards SNS College of Engineering, as it gave me a platform to learn, so that now I came up with a problem and gave a solution using design thinking. I feel tremendous joy and gratitude for everyone and everything who helped me reach this milestone. Thank you for one and all.